Okay. Do you still see the screen with the balloon, Ahmed?
Yes, I can see.
Okay, good. Okay, so let's get started. So if you have questions, clarifications, this is a good time.
Can I start my question, doctor?
Yeah.
Okay, so would like to say it, or do you want me to type it?
If you say, because I'm recording this, so it would help other students who are probably taking exams right now. Maybe if they want to watch it, it might help them. So if you don't mind, if you
Okay.
could say it, that would be great.
Yeah. So my question is, if you're gonna jump back to the chapter one, so between extensive and intensive.
Mm-hmm.
So in a lecture note, there is extensive is volume and mass,
Uh-huh.
and intensive is pressure, density, and temperature.
Yes.
But when I take a look in a book, there is some others. Like there is some others it's not included in these five. So when I went in online, when I did some research, I found if it's divided by mass,
Uh-huh.
it is gonna be extensive. Is that right?
If you divide, for example, if you divide an extensive property, for example, volume, right? Let's see. If you divide volume, capital V, right, which is an extensive property, if you divide
Uh-huh.
if you divide that with a mass, then it becomes an intensive property, which is your specific volume. Okay.
Oh,
Yeah, there are other properties. Energy, energy, if I say just capital E, right, the units are kilojoules. So this is an extensive property. Okay.
okay.
However, if I divide energy with a mass, then it becomes, let's say, kilojoule per kg, then it becomes an intensive property.
So I can see now if anything divided by mass is going to be intensive.
Yeah. An,
Thank
ex-
you.
an, an extensive property, when you divide with a mass, it becomes a specific property, or what is it becomes an intensive property.
Right. That's cool. Yeah,
Okay.
now I get it. Thank you.
Yeah, and there are others out there. It's just that we base the common ones, but you can always look at other properties and say whether it's extensive or intensive. Anything else?
No, that's it. This is my question.
Okay. Kyle, do you have any questions? Or are you just visiting?
Can you hear me now?
Yeah.
Okay. I had a question. I was looking at a problem on the chapter recitation for 3,
Okay.
and I was given a volume and a pressure,
Uh-huh.
and they wanted me to calculate the internal energy.
Uh-huh.
So so I need to first calculate my quality using my volume.
I mean, first you got to determine the state. So you're saying you're given a pressure, right? Um,
Right.
and you're given specific volume, right?
Right.
Okay.
Correct.
So first you look up the tables and decide, whether it is saturated or superheated and whatnot. Okay. So if you find that, and did you find that it is saturated mixture?
Yeah.
Okay.
Yes.
So once you find that, then yeah, you need to find the quality. right?
Okay.
Because remember,
Right.
V average, which is what you are given in the problem, right, is nothing but
Right.
Vf plus x times Vfg. Okay,
Right.
so you know this guy, you know these two because you can go to the pressure table and find those, right?
Correct.
The only unknown is quality, so you can find the quality.
Right. And then I can use the equation U is equal to UF plus
Yeah,
quality
yeah, the same thing.
times UFG.
You,
Right.
yeah. But you have to first do this step where you first find the quality. Otherwise, you have two unknowns here, right?
Right.
Okay.
Correct.
Yeah. So
And then the U average, that's your total internal energy, right?
yeah, the average internal energy per unit mass at that state. Okay.
Right.
Yeah.
And then the second part of that question was to determine the enthalpy of the container.
Uh-huh.
This is done the same way, except now we're using H, right?
Yeah.
But it's gonna be the same basic equation.
Yeah. Did I do it wrong there or?
No, you did
Okay.
it right.
Okay. Okay. Good.
I just wanted to make sure.
Okay.
So
Okay. Good.
that's the only question I have for right now.
Okay. So did you guys look at the chapter 3 problem video I posted?
Which problem video was that? I think I watched it, but I wasn't sure.
The in-class problems I posted that right last week.
Right.
Okay, good. Yeah.
I looked at those, and then I worked on the pretest that you. Oh, I'm working on the pretest as of now that you
Yeah.
posted
I mean,
too.
you
So.
don't have to do tons of those as long as you understand that at a particular state you have to know two independent intensive properties. Once you know that, you can completely determine the state. So you're good. It seems everybody is ready for the exam.
I have a question for you. So, as I'm studying, I see that there's quite a bit more stuff in chapter 3 than that's more intensive stuff in chapter 3 than there is in 1 and 2. Would it be beneficial to study more in that?
I mean, it looks more just because they have to explain. Okay.
Right.
They just have to explain all those different concepts, but other than that, I mean, do the slides run out like hundreds of them? No, right?
Right.
Yeah, so just go explanation. That's it. But all it comes down to is whether you can identify the diagram. Something happened here. Okay, are you able to see the screen now?
Yeah, it's pretty messed up.
Yeah, it'll get better.
Okay.
Did it get better?
Yes, it's good. I can see it for me.
Okay, good.
I got another question for you.
Yeah,
Um, what is the difference between a compressed liquid and a subcooled liquid?
they're the same. They're two different,
Are they?
same state, two different names.
Okay, that makes a lot more sense.
Yeah.
So when you have a subcooled liquid and you're looking at like the property tables for
Uh-huh.
it, is that the same table as if you had a saturated mixture?
No,
Because like
whenever you have a compressed liquid table, if you know you I suggest you go, I told that you have to go to the temperature table.
right, the temperature table.
Yeah.
Okay. 'Cause I was just wondering because there was like I know you have to go to the superheated when you have you go to the pressure where it's hard to explain, but the table with all the different pressures for a superheated.
Yeah.
So there's not one for a subcooled though, right? I'm not missing a
I
sheet
took
or
it out
something.
of the, if you look at your original property,
Okay.
it is there, but I took it out for this formula sheet.
All right. Because yeah, I was looking at the formula sheet you gave us, and then I've looked at the book too.
Yeah.
Like
Yeah.
when you buy the, and in the book they had one, so we're not going to need to know to worry about that.
No, you actually have to memorize the whole table. No. No, I just took it out because you know, it's a limited table and we will never use that.
Right.
If you want, I can give you.
No, I'm fine without it.
Okay, good.
So really, a lot of chapter 3 is just knowing how to use your tables and understanding the diagram, the pressure versus your PV diagram.
Yeah.
Okay. So if we wanted to practice some of those problems, like filling out the chart and stuff like that, there's I think I found those online at one time, but I wasn't sure. I think you had a couple posted on Blackboard somewhere.
Yeah, there are tons of problems if you want to do,
Right.
I don't have to assign anymore. You can pick up the recitation problems, you can try to solve them. You have the homework, you have the textbook examples you can look at, so that's plenty.
Okay, and I looked at the recitation videos for chapter 3, and there was a lot of the ideal gas. Is that included on this test?
You tell me, did you look at my email?
Did you send one out? I totally missed it.
Okay.
So I'll look. I'll look. It's all
Okay.
right.
Yeah, you know my response, right?
Right. I'll
Yeah.
look.
Yeah.
I saw the one that you sent today about posting last night's session on Blackboard.
Yeah. Yeah.
Was there a lot of good stuff in that? Was that worth watching the 40 minutes or so of what it was?
I don't know. I just recorded, but one of the thing is, first of all, we didn't have many people show up, so next time I have to figure out whether they even need this session. If not, it's not worth my time. And then also,
Right.
if they don't come prepared, generally it is a lot of silence. So it'll be a healthy discussion, and some of the people probably don't know how this goes. So
Right.
yeah, it is pretty relaxed, and you can get a lot out of it. Hopefully they'll know next time, or the first exam will teach them. I don't know.
Yeah.
Yeah, and I know that some of them are in exam right now, so that's why I just recorded it, because I don't want somebody to tell us that it was a disadvantage that they missed this. So it's up to them to watch it. you know.
Right.
Yeah, yeah.
Homework wise, I feel like the homework problems that we were assigned on Connect
Uh-huh.
are, I wouldn't want to say simpler, but are not as going to be in depth as what the test questions probably will be. Is that a good assumption?
Okay, okay, you can wipe that question away. I mean, you've had some difficult problems in the chapter 2. I'm glad you found them easy, but there were some problems where you had to spend some time. So not,
Right.
yeah, and some maybe they were easy because you looked at the recitation video or something. So yeah, I mean, if you
I
can't,
didn't.
yeah, if you can't solve a problem which I give you tomorrow, that means you're not ready for the test or you don't know the stuff. But if you look at a problem and say I don't know anything about it, then it's a problem. You should be able to, at least get majority of it. That's all I can say
Right.
yeah, but I cannot really,
Like,
yeah, tell you what the problem will be.
right. I
Yeah.
meant more as along the line as it's going to be like three longer length problems,
Yeah, exactly.
more in depth problems.
Yeah, the pretest was supposed to tell you how many problems you have,
Okay.
and that's exactly what it is.
Right. So we won't have any, like, there was a mixture of long and pretty quick, simple ones on the homework, and we probably shouldn't expect any of the quick and simple. It's going to be like three
Okay,
longer problems.
Kyle, if you want, I can add two more, and I'll tell everybody that you wanted two more, so I can do that. That's not a problem.
No, it's fine. I'll stay with three.
Okay. Yeah, let's take it from there. I'm gonna build from three and see how you guys are doing. If everybody gets it, then it'll be five next time.
All right, sounds good.
Yeah, yeah. So how did your fluids test go, Abby?
It was really hard.
Okay,
I got two of the questions, but then one of them was just difficult.
okay, that's good.
Something we hadn't seen before.
Yeah,
Okay,
that's what Corey said too.
cool.
Could we do a problem like the problem 250 that you put on the practice test, but with the temperatures being different? Like for this one, the outside and inside temperature were the same.
Which one? This one?
2.50, yeah.
Uh-huh. What do I have to do?
Well, like for this one, we only had to consider the electrical energy, sort of,
Yeah.
and because the heat was the same.
Uh-huh.
So could we maybe do an example of one where the heat was like warmer on the outside or something?
I have to give you, because we didn't talk about conduction, convection, or radiation. So I almost have to give you that we are losing so much of heat. So it's like you just add or subtract a number. That's it.
Oh, okay, cool.
You see what I'm saying?
Right.
Otherwise,
Yeah.
you have to know how to calculate the conduction through the wall, the convection outside, and all that, which is not part of this class. You know that
Okay,
that
so
is, yeah,
if we had
that's
that problem on a test, it would just say you're losing so much
yeah,
heat.
yeah. And I remember when we talked about these concepts in chapter 2, I said, in this course we don't really care how this, or in what form this Q is being added or released. We don't care as long as we can figure out what is the number. We don't really
Right.
go into the actual processes. We will calculate them, but we will not really worry about conduction, convection, radiation for this class.
Okay, cool.
Yeah. So you guys know that there is class tomorrow, right? Okay, good.
Can you hear me?
Yes.
Okay. I had a question for on the homework assignment that we just did. It was the one with the diesel combustion piston,
Mm-hmm.
and I was confused about why the mass ratio was what it was, because I actually had James help me out with that one, and I
Mm-hmm.
was confused about how to get that from the air to fuel ratio.
Okay, so let's see. In a diesel engine, we will talk about this later on. Um, can you turn off your mic because I'm getting okay, thank you. So in a diesel cycle, you don't have a spark plug. So initially you have compressed air and then fuel is injected and then it gets ignited because of the compression, and that's how you get an expansion stroke and so on. Anyway, so what you have is let's say if you want to find the ratio of masses, right? Initially, the mass, what is the initial mass? What is M1?
I don't remember exactly what it was on the problem, but is that what you're asking?
Yeah, can you turn off the music or something? There's something in the background.
Can go to a quieter spot. Hold on.
Yeah, that would be good because I'm trying to record this. They'll think we are in a restaurant. Yeah, I'm not looking for a particular number. I'm just saying just what I explained. Initially, what would be the mass? Is it mass of the air plus mass of the fuel, or mass of the fuel? Okay, let me go over that again. In a diesel cycle, first there will be air which will be compressed, and then the fuel is injected. So can you now tell me what is the initial mass? Okay, so he left. Probably he'll be back. So yeah, mass of air. So what will be the final mass? Okay, he's back. So the initial mass is mass of air, and the final mass is mass of air plus mass of fuel. Okay, but in the problem, what we are given
Okay.
what we are given is just the air fuel ratio. That means we are given mass of air over mass of fuel, right? that's
Okay.
that's what we were given. Okay, so you have to do a little bit of algebra here. Can I divide the numerator and denominator with mass of fuel? Can I do that? Can I do this? Am I changing anything? Do you guys see that what I just wrote? Okay, so nothing gets changed because I'm dividing by the same quantity, right? And then what is this guy? That's the air fuel ratio which you are given, and even this guy is air fuel ratio which you are given. Okay, do you now see that you can use that to find the masses? Evan?
Yeah.
Okay, good.
Well, yeah. Oh, sorry, thought I lost you. I think it keeps disconnecting. Yeah. Okay. So I'm kind of confused of where the +1 came from on the bottom there. Yeah, my connection is kind of messed up, so sorry.
Okay. I divided by mass of fuel on numerator and denominator. So I have mass of fuel over mass of fuel, which is 1. You can type if your audio is bad, Evan.
Okay, how would I do that? Let's see.
All right, Evan. I wanna say next time, please try to be in a quieter room because this gets recorded and I don't want this loud noise. Okay. Yeah, you could just type if you can't get that music off. Derek, can you hear me? Okay. I think you're trying to talk, but I can't hear you. Maybe you need to push the talk button, Derek. Otherwise, you can type.
I can hear you all right. Can you hear me?
Yeah, I can hear you now. Oh, yeah. So, I haven't seen you submit your stuff. I know you have done it even before the deadline. I've not seen you submit the evidence.
I still need to do that. I'll do that tonight.
Yeah. Okay, do you guys have any other questions instead of all this silence?
Yes, I have a professor.
Yeah.
In chapter 3, you mentioned class practice 3.1 to 3.3. So in 3.3, there is a question is kind of confused for me. I can read it. Is there any difference between the intensive properties of saturated vapor at a given temperature and the vapor of saturated mixture at the same temperature?
So is it the example you're talking about?
Yes.
Okay. So 3.3, let's open that.
Page 151.
Oh, okay. So is this the volume and energy change during evaporation?
Yes.
Okay, so what's your question there?
Is there 3.3 C?
Okay.
So is there any difference?
I don't have a C, 3.3 C. I have A and B.
Page 151.
It might not have the same page. Are you in chapter 3?
Yes.
And you're saying example 3.3?
Yes. No, problems. Problems 3.3. Sorry.
I never said 3.3. Problem 3.3. Yeah, I probably would have said examples, but
Oh,
yeah, 3.3 is a conceptual question. I wouldn't have asked you to just look at that. You know, I said examples in the book.
I got it.
Okay?
Thank you.
Yeah. Okay, anything else? If you don't have any more questions, I think you guys should relax and okay, what about problem 250? Why is the temperature given? Yeah, you don't have to use it because it's the same temperature as the outside, right? So yeah, you don't necessarily have to use everything given sometimes, and it's one of those instances. I mean, I think the way I look at it is, instead of saying consider room initially at an outdoor temperature of T1 degrees centigrade, they just gave you some temperature. But the key there is that no heat transfer to the walls. So that's the key. So where are you guys? Are you guys at home or on campus? Well, everybody's at home and I'm on campus. I generally do this from home, but I decided this time I'll try here.
I have a question about just kind of the format. Should we expect some like a section of conceptual questions and then a section of like problems that were on the example test where we have work them out, or what else should we expect?
All of it.
Okay, that's kind of what I figured.
No, I'm kidding. I mean, the reason I gave you the pre-test is to tell you what will be the format for the actual test, right? Uh,
Okay.
I mean, there are. Kyle also asked if so since you guys asked me, I can throw in some more questions. I don't mind. It's very easy. Okay. I'm not doing a good job of selling this pre-test business. Okay. How however the pre-test is looking right now, that's how you'll be having. Fluids is long gone, buddy. Last semester. It's a different ball game now. Okay, since you guys so much want this stuff, so I'll make sure from next time I'll have multiple choice and stuff. Maybe not this time. So the reason the temperature remains the same is because your final state is saturated vapor. So and then your volume is right there, so it has to be a straight line between those two. So it has to be an horizontal line, and that's how a constant pressure line looks like on a TV diagram, horizontal in the saturated line. So that's why it is also horizontal. Got it, Alejandro? Okay. Yeah, remember, I'll give you the say a PV diagram or a TV diagram with the vapor dome. Okay, so on a TV diagram, this is how the constant pressure line looks like. On a PV diagram, this is how the uh, constant temperature line looks like. Okay. Why? What is the problem if I give R134A? I mean, is the way you found values or properties, is it different between R134 and water? Yeah, then you should not ask that question, or you should not be worried. Okay, just go to the right table, that's it, and the right appendix.
Yeah, I about screwed up on the quiz the other day. I started in degrees Celsius, flipping through all those tables, and then I figured out it was
Yeah.
in Fahrenheit, so I had to go back and redo it all.
Yeah, so that's one of the things. I mean, you got to realize what is the fluid that tells you, where to look, and also you got to look at the units. And if it is English, you go to the appendix 2. Okay. Yeah, the actual idea of solving those still remains the same. It doesn't matter. Any other questions? I'm gonna post this whatever for whatever it's worth, so that nobody feels they're left out. What is a Dr. Pakala helpful tip for the test? Well, don't do too many problems, just know your concepts, you'll be fine. Just be careful with the units, read the problem carefully. You have plenty of time, so there is no reason to panic. Good. Alright folks, anything else? Should I hang up then? Welcome. So I'm gonna have the office hours as well tomorrow, so you can stop by. Okay then, so then can I sign off? Okay, cool. Alright, see you guys tomorrow in class. Bye bye.